All right, so now that you've wrote this problem down, a couple things that we want to mention or talk about before we get too far in depth with these is when we are solving for some of these problems, especially when it comes to that of accelerations, it makes a difference if it is traveling in the horizontal plane as opposed to the vertical plane. Usually if nothing is acting upon this and it's moving in the vertical plane, it is accelerating due to gravity, and that value would be what because of gravity? It is a positive value, and it's a constant. I'm sure someone can think of it. No. Nope. It's a number. What's that constant? Nope. Then you'd be going in a circle. Yeah, it's the acceleration, but what value is that due to gravity? No. It's a number. What value is that? Say that again. It is 9 something. No, it's not 98. No. 9 point something. 9.8 meters per second squared is the acceleration due to gravity. The reason that's important is because masses will not change. It's a way of calculating your weight because, as we know, you do not weigh the same on Earth as you would the moon, as you would on Jupiter, as you would on any other places that has a gravitational pull. So that is what gives each object, including ourselves, a type of weight on Earth. But if it's not moving in this due to gravity, then we must calculate it if it's moving in a horizontal plane. Okay? So with that, one of these problems is perhaps a little more difficult than the other, or maybe you could say they're both equally difficult. But here again, if you choose to do things or approach this the way that we ask you to, I would have to be led to believe you're going to understand it more. And plus, I think you would agree that it's probably the right way to do things. Is there a reason when we ask or tell you to do something? There's probably a pretty good reason for it if we choose to do what we ask you to do. But some people just choose not to do that. I don't know why. Okay? Is there either one of these that you would like to tackle first? The blue writing or the black writing? Okay? So if some people are watching this at home once this is loaded up, it says an investigator is looking into a car crash as the car struck a pillar on a bridge with 39,480 kilograms per meter per second. The mass of the car is 940 kilograms. Over this time frame of 4¼ seconds or 4.25, how fast was the car moving before the driver lost control while moving at 2.82 meters per second squared? Okay. Is there anything that jumps out in your mind right away? There are different variables we want you to account for. So you've read the problem. What is the next thing you should do? What do we know in this? Oh, your setup. What do we know? Okay, so P or momentum is 39,480. The time is 4.25. Okay. We know the acceleration. I'm intentionally skipping something, see if anybody caught it. Okay. Is that all we know? So what is, and this is a hard problem. No one's going to deny that. What do you think the question is asking? What type of velocity? What type of velocity? The initial velocity. And when we're saying the initial, because one, we're telling you it's the initial velocity, but according to the way the problem is worded, how would you know it's the initial velocity? It's saying how fast was the car moving before the driver lost control. So what that means, driver's moving along here at a certain speed, then maybe a patch of ice, maybe an animal ran across the road, or maybe an oncoming vehicle of someone who wasn't paying attention to what they're doing. It's on the interstate. I don't know. That's not what we're concerned about. But this investigator is looking, well, how fast was he going before he lost control? Because when we look at this formula, okay, what two things can we arrive at when we're talking about momentum? Mass and final velocity. And we need that final velocity. We don't have it, but we can certainly solve for it. So, what do we do to find that so we can get that? Because why can't we use the acceleration formula? We don't have any velocities in there. You have to have 3 of those 4 variables. We only have 2. No. We have momentum. Which one? We can solve for the final velocity. This one right here. Okay? So how do we go about doing that? No. Because we don't have a distance. We have a momentum. Okay? So what is our momentum? Rather than looking all the way up here, when we look up down here, which variable do we know we need to use? This one, because this is how we label momentums. Okay? So 39,480 equals, what's on our right-hand side now? Our mass, which is 940, and what's our variable? Okay, so how do we get VF by itself now?
Put it over 1.
I wouldn't.
You would divide 940.
Yeah, divide each side by 940, right? So upon doing that, our final velocity, in other words, for those of you watching, this is what we said. These cancel. So then final velocity equals whatever those are divided by one another. Okay? So now we've got this guy. Now we can calculate that initial velocity. And that's something that you haven't done before unless maybe it was in the acceleration formula. Okay. Who's left side? Are we on the bus here? Maybe I should just go by tables and just say 1, 2, 3, and 4. Maybe that makes the most sense. So 1, 2, 3, 4. Okay? Middle, 1, 2, 3, 4, 4, 4, 4, 4. Okay. Right side, 1, 2, 3, 4. All right. So can we erase parts of this? What can't we erase?
42.
We can't erase the 42. So now that we have that, we can get rid of this. Okay. So we can finally solve for that initial velocity. How do we go about doing that? We don't need to read all that content in here. Was something I said? We're just walking out in the middle of class now? That's what I'm getting at. Come on, you guys are all in your own ringleaders back there. What's up with that? Okay, fair enough. People just don't do what we ask them to. That's been pretty common today. I don't know what it is. Okay. How do we go about solving this now? Use your acceleration formula. Okay. So we've got 2.82. I'll bet this doesn't show up very well, does it?
Oh, I can't see that.
Okay. I think because it's light, and I understand, no matter where we go, no matter what lights we turn on, we're going to have a glare. That's, we can't get around that. You may have to just shift your head around or swivel to the left or the right. Life's full of little challenges like that. Kind of like this class, right? I got to face it. Life's full of little challenges every day. There's 20 plus of you in here. Okay? But you're not that bad.
There's only 28.
Okay, there's 28 of you ding-dongs in here. Okay. So we're still recording. Still have sound. Okay. So what's on our right-hand side now?
Final velocity minus initial velocity times over.
Inflection order.
Over time.
4.25.
Oh, okay. 4.25. Is there anything else we can put into there?
That's the final velocity.
Okay, we just solved for that. Okay. Now, how can we make this a nice linear equation?
Well, it's 2.82 over.
Okay, does everyone understand why we would do that? Because once you put this over 1, what is that telling you that you're going to do? You're going to cross multiply. Okay, so what is 1 times 42? Okay, what is 1 times minus VI or negative VI? Negative VI. Okay, what is on our left-hand side? If we cross multiplied here, what do we do with those two numbers? Okay, and 2.82 times 4.25 gives us? 11.985. Okay. All right. Now we're subtracting on the right side. Use your algebraic skills.
Okay.
What are your algebraic skills in this fashion? How do you get VI all by itself? Add it to the other side?
Yeah.
Okay, we are saying we add it. Okay, well, this must be 53 equals 84 minus VI. Oh, we subtract it, yeah. I was just being a putz, so sorry. Yeah. If we're not going to add 42, what are we going to do? Okay, so what do these 42s do?
They cancel.
They're gone, and so is that. That takes this variable with it. Okay, so what happens when you take 42 from 11.99? Give or take, something to that effect. Okay, that equals what? We've got a problem here. Yes. What did we say about all velocities, they have to be what? Or they are what? They're always positive.
Well, the VI is negative because they cancel.
You're 2 steps ahead, which is a good place to be. Okay? There's one way you can look at this. Since these are both negative, have a negative sign in front of them, you can either divide by -1 or you can multiply by what? What happens when you multiply -2 times -2? You get 4. So for the same logic then, these two negative signs, they will cancel each other out. So therefore, that car was traveling approximately 30 meters per second before they lost control. And as an investigator, that may be important for a variety of reasons. And maybe it's for insurance purposes. Maybe it is for a criminal investigation. Okay? So, we tackled a pretty tough problem. But do we feel a sense of accomplishment once you have done that? We hope so. Don't kill any brain cells doing that. Although you're doing pretty well in here, I think. But just don't kill any brain cells doing that. Okay? Okay? Can we close the books on this top problem? Be aware that you could see something like this. So for those of you who write these down, who follow this along and do things the way that we ask you to do them, what's your success rate going to do? Be about the same? Maybe. But the chances are pretty good. You're probably going to do better in this class. Make sense? All right. Okay. So with that, one of the aspects, this kind of reminds me of two things. What's that?
Said you gotta circle your answer.
Oh, I did not do that, did I? Okay. So initial velocity is 30 meters per second. Oh, I can do this. I'll do it twice. Okay. So
Oh, you don't have to do the .01.
that's close enough. Yeah. When some of you who do go off to college, you're going to find out you have to take classes that you don't want to. You have to take, well, I'm going to be a business major. You still have to take 8 credits of science. Well, I'm going to be a math major. You still have to take a certain amount of English classes. One of the things that I took was called Prairie Literature. It was just an elective I chose. It reminds me of a show of Little House on the Prairie. Has anyone ever heard of that? Okay. Hey, we found our way back at least. Okay. So back during, let's say, pioneer days, like on Little House on the Prairie, or it was called Giants in the Earth was the name of the book. Read it. Pretty good book. Enjoyed it. And it was about a family that moves out to this area of the country, let's say in the 1840s, 1850s. What do you think that would be like? All you see is open plains here. Maybe so. But if you were going to try to make a well, you really don't have a depth finder to figure out how deep that mine is, or well, or whatever it is you want to try to determine for digging purposes. I mean, if this well is 200 feet deep, do you really have the technology to get that deep in the 1800s? Maybe not. If it's 30 feet deep, you might have a better chance. But if it's 200 feet deep, that might be a little more difficult. But we'll go where the numbers lead us. This is where you will be utilizing your physics or problem-solving intuition, if that's what we got, which we hope so. Okay? So in this case, okay, a farmer during pioneer times, or what is the depth of a mine shaft? A rock falls for 7 seconds as it was let go by a pioneer to see, well, how deep is this shaft? Only way you can do that is if you drop a rock down there or something to that effect. Okay? So what you would do, what are some unwritten numbers here that you have to account for? Like this, right here.
Acceleration of gravity.
Okay? So what do we know about a rock right now?
Zero.
Something about zero.
Initial.
Okay?
Initial velocity.
So some of you have been given the variables. You said this one, and you said this one, and what else do we know? What's the time? What's the acceleration because it's going down in this component? And what's this one?
Zero.
Okay, now you might be looking at this and saying, well, what's the depth? What do you suppose we mean by depth? How deep it is in distance purposes. Probably measured in what, feet? No, meters. Okay? So upon doing this, how can we get one step closer? What formula has distance in it? The velocity formula does. But what's the problem with this right now? We don't have the final velocity. That's right. So, in order to do that,
Where did you get the acceleration?
this, because it's moving in the vertical component, and when objects are falling towards the Earth, typically it's at 9.8 meters per second squared. Acceleration and velocity are related. They're not the same thing. It can't go faster than 9.8, but it speeds up. There's different factors. Air resistance. Air resistance is probably the biggest factor. But anyway, as we look at this, we want to find that final velocity. And how do we go about doing that? Okay, so do what the formula tells you to do. What's on this side? What's on this side? Now, we've accounted for that initial velocity over here, right? What happens when you subtract 0 from a number or a variable? You get the same thing. So if you don't want to put the 0 here, that's fine, because that's just using the old noggin. Okay. Okay, so when we take 9.8 times 7, what is our final velocity? 62. Okay. Now, notice that is a velocity. That does not tell us the depth of that mine or well or shaft or whichever. But what information do we have left? It is. But that is a velocity. That's not a distance.
You have to do 16.6 equals distance over.
Right. We need to take this number, in other words, velocity equals what over what? Distance over time. This is the one we want, right? Well, we've got our velocity 68.60 equals, okay, what is on the other side of that equation?
7. You have to divide 7 by 6.
Okay. Then we've got our distance over 7. Okay? So distance equals
9.8.
You multiplied.
Oh, yeah.
Smart person.
okay? So that might be a little too deep for what you might want to try to do. Okay? You go where the numbers lead you. That's pretty deep. Okay? All right. Meters. All right. figured it would probably take this long, but just think when you have to solve for these, it's going to take you a long time if we're even doing it the right way. The problem with that is when you have 5, 6 to 7 problems and they take this long and we sit and scratch our head and say, I don't know what I'm doing, maybe we forget that information. But that's one of the things you have to be able to overcome. When you see that term quiz or exam or test, you have to find a way to get past that. All right, if there are no more questions, we will work on papers that I'm going to sign here shortly. You have got time to work on these tomorrow. Remember the first week that we were here, we said, I know there's going to be athletic events that you have to travel to. I'm giving you another assignment, but is it due tomorrow? No. How many of you don't like that? That's due on Thursday.
Yeah, it's not really fun.
What are you talking about? It's the one where
If you like it, do the next day. If you like it, then it's due on Thursday.
We want it due tomorrow. How many like that it's due on Thursday? Oh, it's not everybody, but close enough. All right. So I've emailed some of you. I'll continue to do that. That's all I have. First day. We'll catch up to you next time.